Now that we find our way around Redshift inside of Houdini, and now that we set up our scene with an area light and this light dome using an HDRI, it's time to do some proper shading on our object. We want to use the point color of the object to drive the shader. And the object, fortunately, already has point colors on it. If you remember, if you dive inside of the object, here we have this color node defining the point colors of the object. If I make this visible for a second, you see that I have this color ramp that is driven by the IVal attribute that is created inside of this loop here to define a color on the points of these individual onion skins. So the I value here basically is the value of the iteration. We have 15 iterations and the value starts at 1. So this value goes from 1 to 15. And we did a little mistake here because we used a range between 0 and 15 to color our object. So let's fix this by putting a 1 here. And now we are going from green inside to red outside. So it's nice to do this because now we can just color our object interactively and the changes are reflected immediately here in the OpenGL view. And we can send this color to Redshift to use it inside of a Redshift shader. But this method has a downside to it, and that is that this ramp and the point color is geometry data. And that means it has to be updated on the graphics card every time I change this ramp or one of these knots here. And that is quite slow. So there is a better way. Why not dealing with the colors inside of the shader instead of the geometry level? But nevertheless, we somehow want to bring this information about the I value or the color to the shading network. So instead of using the actual colors here, let's do a little trick and just use a black to white gradient. So let's bring this knot down to black and that one here to white. Now we have a gradient between black and white on our object, and we can send this to Redshift and use it as a driving value for a color ramp inside of our shader. Before we go to the shading context, don't forget to put the display flag back to this normal node here. Wait for Houdini to compute the changes and then switch to the shading context. Let's dive inside of the sculpture shader. And remember that we already created one Redshift material that is very basic at the moment. It has a green color for diffuse, and we want to use the color we defined on the points as a diffuse color. So we have to somehow import it here to this Redshift material context. And there is a node for this, as you might have guessed, and it is called rs point attribute. If you lay down this node, it says particle attribute lookup, and this has historical reasons because it started as a particle node, but today it reads particle colors and point colors and everything. So all the attributes there are on points. I don't know why, but the attribute defaults to UV tangents, but what we want to import is CD. And because CD is a standard attribute of Houdini, it automatically gets exported to Redshift. If you want to use a custom attribute, you would have to create an object parameter tag and explicitly state that you want to export the attribute to the shading context. Not necessary with CD. So now that we specified CD here in the attribute name field, we get the point color here at this vector port. And we can use it to drive the material. There are two ways to connect the nodes. We can open up this area here and connect it to diffuse color, or we can just drag this onto this little arrow and then we get a menu and can choose diffuse color. It's the same. Now that we did this, let's open up the render view by clicking on this button here. And you see that we now imported successfully CD from the geometry context into our shading context and use it as a diffuse color of our shader. Okay, now let's do the actual coloring. For this I created a new node called a ramp node, rsRamp. And that serves this ramp here that can be used to define a color ramp. And you can just put it here between the incoming gradient and the diffuse color. This maps from a vector to a scalar, because the driving value of this ramp is a scalar, but as all the three channels of this vector are the same black to white gradient, that is not a problem at all. Nevertheless, something seems to be wrong because everything renders black. And that is this source dropdown here. It defaults to UV map, and that means it uses the UV attribute to drive the ramp. And that is not very useful in our case, so let's switch this to Alt. And Alt means that it uses whatever comes in over this input port. So now that I have this set up, I now can generate a ramp here, and by moving the knots I can interactively tweak my color values. And instead of changing the geometry data, I just change the shader data. That means Redshift only has to update the shaders on the graphics card, which is much faster. So interactive look dev is a lot easier this way. So let me import the color ramp that I defined on the title graphics, because I already created quite a gradient here. And let's use this one instead of the new one, like so. And we get the colors from the title graphic. Maybe I get another angle here, like so. Okay, great. Now, by moving these knots around, I can explicitly state which slice of my object gets which color. So here, for example, I have this red part, which really colors just one of these slices. Maybe I move this a little bit. It's really totally up to you how you want this stuff to look. And now you see that the red color is on two of the slices, and I want to have even more red. Now it colors the inside of the next one. Maybe move it back a little bit, just to have only one red stripe here. Maybe we move this one too. So now one of the onion skins is red, it's colored red. But it doesn't stop here. I not only want to define the diffuse color independently for all the onion skins, but I want to define the material properties. And that can be done here in the material. So, for example, I can dial down the reflection for everything, and I of course can use emission. That means this material not only can be diffuse or reflective, it can emit light too. And emission is not here in the base properties, but emission is found here under the overall tab. It has a weight, so at the moment the emission weight is 0, but if I go up with this weight, I have some emission here, and if I now change the color from black to something else, I get an emissive object. What I want to achieve is that I only have emission here on my red stripe, because I want this to glow. So what I'll need is another ramp node to drive this emission, because of course you can set this emission weight, but another possibility to control the emission is the emission color. If I have black here as the emission color, no emission happens, and if I have another color, the emission will happen. So get rid of this initial node here, and by Alt dragging, just duplicate our ramp node. And now let's get rid of all these knots here, all the knots, but the 4 knots defining the red area. And let's set here this border knot to black, and the other one too, such that I only have one red stripe here that lives in the same parameter range as here on my diffuse color. And now I can go to the overall section of the material and connect this new ramp to the emission color. And what happens now is that this material here, or this part of the material, is emissive. So now I mixed 2 effects by using 2 different ramps. I have a material that is diffuse and emissive in some parts, here by just using 2 ramp nodes. Okay, now let's try something else. Let's try a texture. So to import a texture, let's lay down our RS texture node and click here on the chooser, and then we can just go to episode 9 and choose this roughness JPEG. And if I want to try this out, let's create a new material to be used with this texture. So connect the texture to the diffuse color, and instead of using this material, let me quickly make this a little smaller by folding the sections. And now I can try this out by just connecting it here to this initial port. And you see that you don't see much. And that is because our object does not have UV coordinates. So Redshift has no clue how to map the texture onto our object. So one possibility would be to go to the geometric context again and create UVs. Another possibility is a node called the triplanar mapping. So lay down a triplanar node, like so, and connect this texture sampler here to the first image, image X. One image is enough because we have this setting here saying that the same image is used for all the three axes. And what the triplanar node is doing is it is box mapping basically this texture onto our object. So it's projecting the object from the X, Y, and Z direction, and it is blending the seams automatically. That is of course not high quality texturing, but for a lot of stuff this is enough. So let's use this here with our diffuse color, and let's see what this gives. And you see that now we immediately get our textured result, because now we have a triplanar blending of this roughness texture. And especially with textures like this one, that basically are stochastic, this triplanar node often is totally enough. I only use this texture here in the diffuse color to see the mapping, but I intend to use it in the roughness channel of this material. So by pressing Y, disconnect it here and connect it instead to the roughness channel, reflection roughness. And now we drive the roughness with this texture here. So go to the material, and you see, now that you connected this port, this roughness is gray. You cannot change it here anymore because it is set here by this wire. Now we can control the roughness through this texture. But the roughness is very sensitive to the values. So we need another ramp to control the color values of this map. So let's create another ramp node, RS ramp, connected here in the middle. And let's switch this to Alt too. And now you can see if I set both of the knots of this ramp to black, that I get a glossy result here. And if I set both to white, I get a very rough result. To see this better, you can go to the material and just increase the IOR, say to 6, because this means just more reflection or less reflection fall-off, just for now to debug the roughness texture. So again, let's quickly go back to black for both knots, and you see now it's very, very specular. And now you can just fiddle with these values until you reach some good values for the roughness. What we want to do is we want to find a range of the texture that can be used to map to different roughness values to give a nice rough impression with some imperfections on the surface. So we want to go up here with the roughness. And let's quickly switch to the progressive mode because it's easier to tweak these settings here in the progressive mode. And let's find the area of the texture where this gives really nice individual or nice different results. I think here this area is a nice area. And now maybe go down with this second knot a little bit, just to get some variation in the roughness, like so. That is something very typical to real-world objects because they always are dirty and worn, and that is reflected in the roughness often. So I like this, and because I want this to be golden, let's go to the diffuse color and set it to something orangish. But at the moment, this is still a dielectric, so it has white specular reflections, and it does not look very metallic. To make it metallic, what we can do is we can switch the Fresnel type from IOR, which is the old workflow, to metalness. And that uses the new PBR metalness workflow. That is basically a value that works like more or less like a Boolean. This metalness value just states if the object is a dielectric or a metal. So if the metalness value is 0, it is rendered with a dielectric BSDF, and if this value is 1, it is treated like a metal. That means that the diffuse component is more or less entirely eliminated, and instead the reflections are colored. So this value really switches between, so to speak, two different materials. And it's so much easier than setting this up with a IOR. So let's put 1 here for the metalness, and now you see that I have a metallic surface that I can use. Okay, the next thing is that I don't want to stop here. I want to use the same texture as a bump map. To do that, create a bump node, bump map, and just connect the texture here to the texture input of the bump map. And this bump map is then connected to the material here under the overall tab, like so. And if I do that, I get a very, very strong bump effect. I don't want that. So let's dial down the height scale to something a lot smaller, like 0.005, say. Okay, now I have a little bit of bump here, and this overall looks like a nice metal. So now I have two setups. I have this color setup here, and I have my metal setup. And what I do now is I want to use this material, this metal material here, only on some of these objects. Not on the entire object, but only on some onion skins. So I have two materials, and what Redshift allows me to do is to blend these materials using a specialized node. Let's lay down a RS material blender. Here it is, the RS material blender, and that allows for blending up to 6 different materials. And it works like this. It has this base material here, and you can connect your base material to this base material port. And then you have 6 layers. If you open up layer 1, you see that you get 2 input ports, the layer 1 color, and that is the second material. And then you have this blend color, and this blend color is used to blend between the base color and this layer 1 color here. And then you can repeat the process with layer 2 and so on. So let's connect the out color of material 2 to this layer 1. And now I have 2 layers, 2 material layers. If I make this smaller, a little bit more tidy, and instead of this material directly, we now want to connect this material blender to the surface. And now it goes pink, and that is because if you're using point color, Redshift has to know about the point color on export. And we started the IPR with the second material in place, so Redshift did not know about the point color. That is one of the cases where you have to refresh to get the correct result. As soon as I refresh, the point color is evaluated again, and I get the correct result. And at the moment I only see material 1 because the blend color is not connected, so it defaults to black, and that gives me the material 1. So to mix between the two materials, let's create just another ramp that is driven by the point color. So duplicate the ramp here again, and let's set these 2 knots here to white, because the blend color is really using black and white to determine which material to show. And now we can connect this ramp to the blend color. That was wrong, to the blend color. And as soon as I do that, you see that I get this metal here on the red part of my object. Well, aesthetically speaking, this is not perfect, so let's move this to a different area. And by doing so, I can really choose which area of my object I want to make metallic, like so. To get rid of this knot, I start with the metal here, which looks quite nice. So why not doing this? And I can maybe fiddle around with this a little bit to put this pink here, like so. That is really totally up to you. Okay, maybe go to the tree planar mapping and increase the scale to make it a little smaller. That looks nicer, and maybe we even change the color of our metal to something a little less saturated and a little lighter. That looks quite nice. Like so. And now we have a nice blend between our metal material and our color ramp. So this is two ways of controlling different material effects on one and the same object. One way is to really use mapping. Doesn't matter if you use UVs or a color value, like in our case. And the other way is to do material blending. So if you have some sophisticated material effects, material blending, it's usually easier than mapping all the individual channels of one material. And it really makes not much of a difference regarding performance. Okay, the only thing that is left is to go into the spheres material and change these spheres to something else than this strange blue. Maybe let's create black spheres without any roughness, or just a tiny bit of roughness. Like so. And now we have a shaded result of our object. So I hope you learned something about redshift shading in this tutorial. Next time it will be about setting up the redshift renderer to get rid of the noise.